I'm going to do an example here. I'm going to do it in two different ways, but I'm going to use the direct comparison test and the integral test. But here's a key for using the direct comparison test, the way I'm going to do it. If this series diverges, so does this series. In other words, if I take away one term or if I take away two terms. Well, why is that? Well, if this is equal to infinity, so is that. Well, that's that series. Just taking away one term doesn't change the fact that it's infinite, nor does taking away two terms, and that this series here is this series. That's the key. So my observation is that I'm going to compare natural log n to n. Now this is usually greater than 1, but it's greater than 1, that's greater than 1 if n is greater than or equal to 3, and we know that because the log 3 is greater than 1, and log 4 is greater than log 3, which is greater than 1, and so forth. So that's the key. So what this means is that this series, starting at 3, is greater than this series, starting at 3. Now, since the series, harmonic series here, starting at 1, diverges, so does this series. Okay, so that means that this series, therefore, this series diverges. Well, because this series diverges, so does this. So basically, since, using the basic comparison test, since n equals 3 diverges, and natural log of n is greater than n is greater than 1 over n, so does this series. And that's by the direct comparison test. Now, since this series diverges, so does this series starting at 2, and that's the given series. Okay, so we know that this series diverges. Okay, now I'm going to do this using the integral test, and so I'm going to use, just notice that I'm going to use the integral test. I'm going to integrate to infinity natural log n over n. I'm sorry, these are x's. Though you could use that, I guess, if you wanted. And that's going to be equal to this. 2 to b natural log x over x dx. I use this u sub. Du is 1 over x dx. So this becomes limit b goes to infinity, but I'm still keeping with x's. U du, well, this is going to become lim b goes to infinity, u squared. Switch back to x. This is a lot of work, sorry. That's equal to lim b goes to infinity log b squared minus log 2 squared. This goes to infinity, so this is to infinity, so therefore this integral diverges, therefore, by the integral test, so does this series. Okay, quick application of the integral test.